Hello everyone. Once again, I welcome you back to the Tele-Online education program of the Department of School Education. In the last class, we have discussed and worked on exercise 6.2. So we'll be continuing with the chapter squares and square roots with a different exercise now. This exercise will be exercise 6.3, where we will be applying the different methods of finding square roots. So to begin with, let's look at the exercise first question. Exercise 6.3. Exercise 1, question 1. 1, 1. What could be the possible ones digit of the square root of the following numbers? We have already done this in the previous exercises. It is no different. The same thing is repeated again. The first question is 9801. And they are asking what could be the possible ones digit of the square root of each of the following numbers. Now, before we were doing squares of numbers. Now we will be dealing with square root of number. So the same step will be followed. When you look at this units place, it ends in 1. Now this 1 can be achieved through 1 into 1, 1. So this can be a 1 square. And this 1 can also be achieved by multiplying 9 2 times. 81. So here the possibility of the ones digit can be either 1 or 9. So this can be either 1 or 9. Alright, after finding the square root for this, the answer may have in units place 1 or 9. I hope you have understood this. Let's try the next one. Question number 2. 99856. 99856. Alright. Let's look at the unit place number. Now this is 6. 6 can be achieved by multiplying 4 into 4 is 16. That is 4 square. We have 6 in unit place. Another number is there that is 6 square. That is 6 into 6 we get 36. So here also it may have in unit digits place 4 or 6 after we find the square root for this. So in the same manner, we can complete all 3 and 4 at home. We will move on to the next question. The next question is, without doing any calculation, find the numbers which are surely not perfect squares. Now, this is also the same thing as we have done in the previous class. The given number is 153. 153. So this is not a square, perfect square. This is not a perfect square. Why? Because in unit place we have 3, and 3 is not among, we have already discussed the numbers 0, 1, 4, 5, 6 and 9. So this cannot be a perfect square. Similarly, we can solve 2, 3, 4. It is all the same, no difference. You simply have to look at the ones or the unit place digit. Take the unit place digit, compare it with these numbers. If they tally, then it is a perfect square. If they don't tally, then it is not a perfect square. This number, 153, is not a perfect square. All right, let's move on to the next question. The next question reads, find the square roots of 100 and 169 by the method of repeated subtraction. Now this is the first method of finding square roots by repeated subtraction. We have already learned about this in the previous class. So let me do for 100. So what we're going to do is we're going to find the square root of 100 by repeated subtraction. What happens here is we have to keep subtracting odd numbers. All right. The first odd number is 1. So when you subtract 100 minus 1, you get 99. When you after that, you take 99 and subtract the next odd number after 3, that is, after 1, that is 3, 96. Similarly, you continue like this. 96 minus after 3 is 5, 91. Then 91 minus after this is 7, so you get 84. After this, 84 minus 9, you get 75. So 75 minus 11, you get 64. 64 after 11, it will be 13, you get 1, 5, 51. After 13, it will be 15, so it will be 6, 3. 36. 36 minus after 15, it will be 17. So you will get 19. After 17, you will get 19. It comes to 0. We have finally reached 0. Let's count the number of steps that we have done. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We took 10 steps to reach 0. So we can finally see that the square root of 100 is 10. Even without doing this, we know that it is 10. But to prove that repeated subtraction can solve square roots, we have done it. So we have gone through 10 different steps to reach 0. So this number of steps will give you the answer as the square of the as the square root of 100. I hope you have understood this. So 169 will also be the same thing. You start with 1, go on till you get 0. So this will be your assignment. Please make sure you practice it at home. Let's move on to the next question. Question number 4. Find the square roots of the following numbers by the prime factorization method. Now this is the second method of the 3. We have already discussed about prime factorization. We have already discussed about repeated subtraction. Now we will put it into practice. Question number 4, 1. Question number 4, 1. 7, 2, 9. This, we have to find the square root of 7 to 9 using prime factorization. Prime factorization is simply done like this. You can either do 9 plus 2, 11, 11 plus 7, 18. We can do it 3, or we can look at the last digit and you can find out the divisor. Now 3 into 2 is 6, 3 into 4 is 12, 3 into 3 is 9. Again 3, 3, 8, 24. Again 3, 3, 2, 7. Again 3, 3, 9, 27. Again 3, 3 into 3 is 9. 3 into 1 is 3. Now, let me bring it down here. Square root of 1, 2, 3, 4, 5, 6. We have 6 trees. 1, 2, 3, 4, 5, 6. So the next step here is to pair them up. 2 trees, 2 trees, 2 trees. No more left. All of them have pairs. So we can continue. So these 2 will become 3 square. These 2 will become 3 square. These 2 will become 3 square. All of them are squares, so I can take a common square for all of them with a bracket. Bracket open, 3 into 3 into 3, bracket close, square. Cancel the square roots. We have 3 into 3 into 3. So 3 into 3, 9, 9 into 3, 27. So square root of 7 to 9 is nothing but 27. This is the prime factorization method. Please do not get confused. Let's move on to the next question. Now here, I will not be doing that much since all the methods used is same but different numbers. So we will go for one more number, question number 7 maybe. Yeah. 5929. 5929. Square root of 5929. So square root of 5929. So for this we will start with 7. 7 into 8, 56. 56, 32. 7 into 4, 28. 32, 24. When you subtract, you get 4. And sorry, 49. 7 into 7 is 49. So again you can continue with 7. 7, 1, 7. 7 to 14, 7, 1. Here 11 into 11 is 121. 11 into 1 is 11. So you are getting 7 into 7 into 11 into 11. That means 7 square into 11 square. So both of them are squares. I will take a common square and I will cancel up. I'm left with 7 into 11, which is nothing but 77. That means if I multiply 7 to 7 2 times, I will get 5929. Let's move on to the next question. All right, for each of the following numbers, find the smallest whole number. Question number 5. For each of the following numbers, find the smallest whole number by which each should be multiplied so as to get a perfect square. Also find the square root of the square number so obtained. That means the numbers given in the question are not perfect squares. So what we are going to do is question number 1, 252. Solution. So we are going to first factorize them. So 252, we will first factorize. We'll start with 2, 2, 1, 2, 2, 2, 6. So again 2, 6, 2, 3, 7 into 9, 3 into 3, 3 into 1 is 3. So what we're getting here is 252 is equal to 2 into 7 into 3 into 3. Let's pair them up first. First pair, second pair. 7 does not have a pair here. No pair in 7. So what we are going to do is we are going to add another 7. We are going to multiply another 7. Sorry, not add. We are going to multiply another 7 to make this 7 a pair. All right. So what we are going to do is we are going to multiplying 7 on both sides. So we get 252 into 7, and here 2 into 2 into 7 into 7, the new 7, and 3 into 3. So pair them up. You are getting all pairs. Now this has become a perfect square. Now when you multiply 252 into 7, when you multiply 252 into 7, you get 1764. You can check it out here. 7 2 14, 7 5 35 36, 7 2 14. So, sorry, plus 3 is 17. All right, 2 into 2 into 7 into 7 into 3 into 3. That means 7 is the smallest number to be multiplied. 7 is the smallest number to be multiplied to 252 to make it a perfect square. Also, they have asked us to find the square root of the square number formed. So we will find out the square root, that is simply by putting a square on top, square root on top. We already have pairs. This is nothing but 2 square, 7 square, 3 square. Take all common, you get 2, 7, 3. So your final answer is 2 into 7, 14. 2 into 3, 6, 6. So 42 is the square root of 1764. All right? I will be leaving the rest of the questions for you, 2, 3, 4, 5, and 6. All of them will follow the same thing. We simply have to find a number which has no pair and multiply that on both sides of the equation, and you will get the final answer. The same thing, you repeat it, you try it at home. Let's move on to question number 6. Question number 6. For each of the following numbers, find the smallest whole number by which it should be divided so as to get a perfect square. Earlier it was multiply, now it is divide. All right. So we will take the first question, same number, nothing to repeat here, nothing to get confused about, it is the same number. So we're getting, after prime factorization, we're getting 2 into 2 into 7 into 3 into 3. We have pairs of 2 and 3, but 7 is single. So now, earlier it was multiply, now it is divide. So we have to divide these particular prime factors by 7 to remove the 7. So we will write here dividing 7 to, on both sides. That means here and here. So 252 divided by 7 is equal to 2 into 2 into 7 into 3 into 3 by 7. 7 into 1, 7 into 1, 7 into 1, 7 into 3, 21, 42, 36. So final answer we're getting 36 is equal to 2 into 2 into 3 into 3. So after dividing with 7, I'm getting 36. And here I'm getting 2 into 2 into 3 into 3. So, yeah. So we can say that, therefore, 7 is the smallest number to be divided. Also, square root of 36 is square root of 2 into 2 into 3 into 3. So we're getting 2 square, 3 square, 2 into 3 and 6. So square root of 36 is 6. Just by looking at this number, we can say that 6 into 6 is 36, right? So square root of 36 is 6. So this is the same as the earlier question. Question number 5 and question number 6 are very similar. The only difference is one is to be multiplied, one is to divide the extra number. All right. So I hope you can do the rest of the questions at home, practice at home. So without wasting much time, let's go on to the next question. Question number 7. Let's read the question together. The students of class 8 of a school donated rupees 2,401 in all for Prime Minister's National Relief Fund. Each student donated as many rupees as the number of students in the class. Find the number of students in the class. So here the question says, each student donated as many rupees as the number of students in the class. That means if there are 10 students, all 10 of them donated 10 rupees each. If there are 11, 11 rupees each. All right. So we have to find out the number of students in the class. So let's take, let X be the number of students. All right. And also X be rupees X, because number of students and amount is same. So X be the, rupees X be the amount donated by each student. All right. So total amount. Total amount will be this into this. X into X. Now please be very careful here, because X, if we write like this, if we write the normal usual X, X into X, we will not be able to differentiate which is multiply, which is X. So it is recommended you use X like this, multiply like this. All right. Now the total amount was rupees 2401, and this is nothing but X square. All right. So when we remove the square from this X and bring it this side, it will form a square root. This square, if you bring it this side, it becomes square root. Now we simply have to find this using prime factorization. The prime factorization, so we'll begin with 7, 7, 3, 21, 3, 0, 7, 4, 28, 7, 3, 7, 5, 35, okay, 7, 4, 28, 6, 63, 9, 7, 7 is 49, 7, 1 is 7. So we have 7 into 7 into 7 into 7 x. Pair them up. We get 7 square into 7 square x. Therefore, x will be 7 into 7, which is nothing but 49. That means we have 49 students. Total number of students is 49. All right? I hope this is clear. The next question is also the same thing. 9 and 10 are also the same thing, but let me do 9. 10 you can do at home, practice at home. All right, let's move on to the next question, question number 9. Let me read it out for you. Find the smallest square number that is divisible by each of the numbers 4, 9, and 10. Now to do this, we have to find LCM first. LCM of 4, 9, and 10. So to find LCM, again we will factorize 4, 9, and 10. No need to write and. So 2, 2, 4, 2, 9 we cannot. So 2 into 5 is 10. 2 into 1, 9 and 5 cannot be divided. 5, 3, 1, 3, 1, 5 cannot be divided. So again 5, 1. We have LCM as 2 into 2 into 3 into 3 into 5. So we have here 2 into 2, 4, 4 into 3, 12, 12, 3 into 5, 15, 5, 2, 10, 5, 1, 2, 1, 1, 0, 8, 1. So we're getting, we're getting 180. 180 is the product. And now we have to check here. We can make this as pairs. All right. We can make this a pair, but this 5 does not have a pair. Now in the question it states that that is divisible, right? So to make it divisible, we have to multiply 5 on each side. So what we're going to do here is, multiplying 5, we get 180 into 5, right? 180 into 5, so we're getting 900. Therefore, the smallest number that is divisible is 900. Similarly, for the next question, question number 10, we have to follow the same step. If there is a number where a pair is missing, you have to multiply that number with the result that you have got, and you will get the final answer. All right? Now with this, exercise 6.3 is over. Let's move on to the next exercise. Exercise 6.4, we'll try to wind up quickly. 6.4, question number 1, 1, 2, 3, 0, 4. Now here, find the square root of each of the following numbers by division method. We have already discussed about long division method. Now this is the third method, and this is very similar to division. So the first thing that we have to do is divide it, as we have already discussed. Pair them up first. bar, 2, 2. So all of them have pairs. Now we have to find the nearest square. 4 into 4 is 16, okay, less than 23. 5 into 5 is 25. Now 25 cannot be used because this is lesser than 25, so we'll go with 4. 4 into 4 is 16. When you when you subtract 13, 7. Now here you're multiplying 4, 4, so you will add 4 here. Yes, so after this, you have to put another number here and multiply it with the same number. Multiply with the same number, you have to get some 704. So we have to check. The and is 4. So even 2 can give 4. 2, 2 is 4. 2, 8 is 16. But it is nowhere near 704. The next number which we multiply, that can give a 4 in the unit place is 8. 8 into 8 is 64, 6. 8 into 8 is 64. So you're getting 704 here, 8 here, 8. That means 88 into 8 is 704. So your answer is 48. This is a very simple method. You simply need practice. Simply need practice to totally understand what exactly is going on. Let's look at the next number. 2, 4, 4, 8, 9. So solution, square root of 4, 4, 8, 9. To find these again, we will go for long division method. 4, 4, 8, 9. Pair them up. Both of them have pairs. Now find the nearest square. 6 into 6 is 36. 7 into 7 is 49. So we will go with 6 into 6, 36. Add 6, it becomes 12. Subtract this, you get 8. Now, to proceed further, both of these numbers will come down. Similarly here, both of them came down. Similarly, both numbers. In normal division, only one number will come down. In this long division method, two numbers will come down together. Please do not get confused. So here we put this. Now, we have to find the number that will give, we have to find the number that we can insert here and multiply with the same number to get 889. So we can try with 3. Putting 3, 3 into 3, 9, 3 into 2, 6, 3 into, it's nowhere near. So what we can do is we can increase the next number. The next number that you multiply to give 9 will be 7. 7 into 7 is 49. So 9, 4. 7 into 2, 14. 14 plus 4, 18, 1 in hand. 7 into 1, 7, plus 1, 8. So when you put 7 and multiply by 7, you are getting 8890. So this is the long division method. This is, it's quite easy. We just need to practice it a lot. So let's move on to the next question. We'll skip question number 2. Right, we'll go to question number 3. We will do one question from question number 3. The questions which I have left behind, please make sure that you practice at home. This is for you to practice. And due to time constraint, I may not be able to do all the questions, so please bear with me. So the next question, 3i, 2.56, solution. Square root of 2.56. Now, here we have a decimal number, 2 point. Now we have a decimal number. Let's see how we perform this long division method with decimal numbers. Same thing, pair. No pair for this. But we can look for a number that we can multiply 2 times to get 2. There's no such number. The nearest number is 1. 1 into 1 is 1. If you do with 2, 2 into 2 is 4. 4 is greater than 2, so we can't use 2. So we will go with 1. 1 into 1 is 1. When you subtract 2 minus 1, 1. And then since you're multiplying 1 2 times, you will add here 1. So it becomes 2. Now, this number has to come down. 56. But there's a point. So we will put a point, bring it down. Alright, 1 point. Now we have to find some number that which we will multiply with and get 156. So we can try with 4 first. 4 into 4 is 16. 4 into 2, 8, 96. Now let's try with 6. 6 into 6 is 36. 6 to 12, 15. So we're getting 156 when we multiply 26 into 6. We're getting remainder 0. The same thing will be done for all the questions in question number 3. Please practice and yeah. Okay, let me skip some more questions. Now we'll go straight to question number 7. We'll go straight to question number 7. All of them are more or less the same. We simply have to understand the logic behind the long division method. Now, question number 7, A. All right, A. They have given us that AB is equal to 6 centimeter, BC is equal to 8 centimeter. Find AC. And they have also mentioned in a right triangle ABC, angle B is equal to 90 degree. So let's draw a triangle. This is 90 degree, A, B, C. Now AB is 6 and BC is 8. We have to find this. There is a formula called Pythagoras theorem. Pythagoras theorem. We will use this. By Pythagoras theorem, it gives this formula: hypotenuse AC, the longer side is called hypotenuse AC, square is equal to perpendicular plus base. Perpendicular is nothing but AB square plus BC square. Now we have to find, so we know that AB is equal to 6 square, 6, so 6 square. BC is equal to 8, so 8 square. When you take the square, it becomes 36, and this becomes 64. And when you add it, you get 100. Therefore, AC square is equal to 100. Now, when you take the square on the right side, on the other side, it becomes square root. We know that 10 into 10 is 100, so the square root of 100 is nothing but 10 centimeter, since this is in centimeter. So similarly, the other questions will be solved in this manner for 7b. Now with this, as already mentioned, due to time constraint and all, it has become quite difficult to solve all the questions. So I want you to kindly bear with me. But I hope I have done justice and we can, we have learned something from what we have done so far. So let's keep practicing and try to learn. Learning by oneself is so much more better, and the experience leaves you with better knowledge. So work hard, study hard, and all the best. And with this, we'll wrap up the session for today of lesson number 6, squares and square roots. Thank you so much.